Hey everyone, I am Nabarun and welcome to my channel. If you are a backend developer and you have already worked with Node.js, .NET, ASP.NET, Express, APIs, databases, authentication, and all of that, at some point in your interview, the interviewer is probably going to ask you something like design a URL shortener, or maybe how would you design a system like Instagram, or even suppose your API suddenly starts receiving 1 million requests per second. What would you actually do? And this is where many developers get stuck, not because they don't know how to write code, but because system design is not mainly about writing code. It's all about understanding how your code, database, servers, cache, queues, and other components work together when the application becomes large. So from today, we are starting a completely new playlist. It is the backend system design. And in this series, we will start from the absolute basics and gradually move toward advanced real world system design and interview level problems. And yes, we will also write actual backend code using the Node.js only, wherever it makes sense. So let's start from the very beginning. So, what exactly is system design? Let's say I ask you to create a simple backend for a food delivery application. So a beginner might think, okay, I will create some APIs. Maybe we have post users, orders, get orders ID, post payments APIs. Okay. And initially, this might work perfectly. You have your Node.js, your database, APIs, and everything is fine. But now imagine that instead of 100 users, you suddenly have 10 million users, and instead of 10 requests per second, your application is receiving 50,000 requests per second. Now things start becoming interesting. Where are you going to run your application? Like one server. What happens if that server crashes? What if 10,000 users request the same data at the same time? Should every request directly hit the database, or what if your database becomes slow? Okay, like how do you monitor all of your systems? So this entire process of thinking about these problems and designing a solution for this is basically system design. Now let's understand something very important. There are generally two ways we talk about system design in interviews. One is the low level design, or the LLD, and other is the high level design, or HLD. So low level design is more focused on things like classes, objects, interfaces, methods, design patterns, and how individual components are implemented. And high level design is more about servers, APIs, databases, caching, load balancing, queues, services, scalability, and communication between components. For this playlist, our major focus will be backend system design and high level design. But I will also connect the concepts with actual Node.js implementation whenever possible, because I don't want this playlist to become just boxes, arrows, and texts, or the code snippets. I want you to understand why are we putting these boxes or all of this over here. That is much more important. Let's take a very simple example. Suppose uh, we have a Node.js API, something like this. Okay. So at first glance, this looks completely fine. A request comes in, our Node.js server receives it, we query the database, then we send the response to the client. Simple. But now, imagine this API becomes extremely popular. We receive thousands of requests every single second, and many of those requests are asking for the same user or the same frequently accessed data. So every request is doing like this. A request comes in from the client side to the Node.js server. Okay, we query the database, and then we send the response with the help of Node.js server to the client side. Okay, so the problem is that our database is now doing a lot of unnecessary work. So this is where system design thinking begins. We start asking like, do I really need to hit the database every single time? Maybe not. Or maybe we can introduce a cache. Okay, now our architecture become look like this. Okay, so if the data already exists in the cache, we return it immediately, or if it does not exist, then we go to the database. For example, like const cached user equals to await redis dot get and the method and the user ID. Okay, now we have introduced another component into our system. It is the redis. And this is exactly how system design starts. We are not randomly adding this redis because everyone uses redis. We are adding it because we identified a specific problem, like the too many repeated database reads. So that is the mindset I want all of you to develop throughout this playlist. Now let's talk about the most important thing in a system design interview. So when the interviewer gives you a problem, don't immediately start drawing servers. Don't immediately say things like, let's use MongoDB or use Redis, Kafka, microservices. Okay. So that is one of the biggest mistakes beginners make. First, understand the problem. For example, imagine the interviewer says, design a URL, a shortening service like Bitly. Don't immediately start saying like, okay, I will use Node.js, Redis, MongoDB, Kafka. Never. First, ask the questions. Okay, like how many users, how many URLs are created per day? Like, do URLs expire? Do we need authentication? Or what is more important over here, like the read traffic or write traffic? So these questions help us understand the actual requirements. So whenever you get a system design problem, I want you to follow a basic flow, something like this. First, understand the requirements. Second, estimate the scale. Then define the APIs. Fourth, design the high level architecture. Fifth, choose the database and a storage strategy. Then think about scalability and performance. And finally, think about failures, security, monitoring, and trade offs. Okay, notice that I said trade offs. This is extremely important in system design interview because there is usually no perfect architecture. Every decision has some advantage and some disadvantage. For example, caching can make your application much faster, but now you have another problem. Like what happens when the database changes but the cache still contains old data? That is called a cache consistency problem. Similarly, adding more servers can improve scalability, but now you need to think about how traffic is distributed between those servers. That is where a load balancer comes in. And once you introduce multiple services or you have network communication failures and observability problems, so the system design is basically a chain of decisions. Okay, now let's make today's example slightly more realistic. Suppose we have this architecture, okay? So now our application is not dependent on a single Node.js server. If this all Node 1, Node 2, and Node 3 the servers, okay. If Node 1 goes down, the load balancer can send a traffic to Node 2 or the Node 3. If the same data is requested repeatedly, Redis can serve it without hitting the database every time. Okay, so this is already much more scalable than our original architecture, and we have not even started talking about like queues, replication, CDNs, message brokers, or microservices. We will get there. One important concept is the scaling. Suppose our Node.js application is running on one server. So this is called vertical scaling when we increase the resources of that machine. For example, like this, two CPU cores. I'm switching to 8 CPU cores, and from 8 GB RAM to I'm switching to 32 GB RAM. But there is a limit. You cannot keep making one machine infinitely powerful. So another approach is, instead of one server, use multiple servers. That is called horizontal scaling. Now, if traffic increases, we can add more instances like this, like node 1, node 2, node 3, and we can also add node 4 and node 5 servers. Okay, so this is one of the fundamental ideas we will keep coming back to throughout this playlist. Now let's uh, connect this to Node.js. So a very common question, something like this. Node.js is single-threaded, so how can it handle thousands or millions of requests? So the answer is that Node.js uses an event-driven architecture and non-blocking I/O or the input-output. For example, like this. So over here, while the database is processing the request, Node.js does not have to sit there doing nothing and blocking the entire server. It can continue handling other input-output operations. But here is the important part, that is Node.js being efficient does not mean one Node.js server can handle unlimited traffic. At some point, like CPU, memory, network, database capacity, and other resources become bottlenecks. That is why system design is still necessary. And this is where this playlist is going. We are not going to learn system design by memorizing diagrams. We are going to take real backend problems. We will start with simple systems, then we will gradually move toward things like URL shortener, rate limiter, okay, authentication systems, file upload system, notification systems, and many more. And eventually, we will take large interview style questions and design them from scratch. And wherever possible, we will build simplified versions of using Node.js so that you can actually see how the theory translates into the backend code. So if you are preparing for a backend developer interview, don't just learn how to create an API. Learn to ask yourself like, how will this API behave when 1000 users call it? Then ask what happens at 10 million users. Okay, that's the difference between simply writing backend code and actually thinking like a backend engineer. And that's exactly what we are going to learn in this playlist. So this is day one of backend system design, and in the next video we will start with one of the most important concepts in system design is the scalability. We will understand vertical scaling, horizontal scaling, like the load balancing, bottlenecks, and we will build a small Node.js example to understand why a single server architecture eventually becomes a problem. So if you are learning backend development and want to go beyond just crude APIs, follow this series because we are going from beginner level to the real interview level system design. And that's it for today's video. I will see all of you in the next video. But hold on, don't just watch. Please like this video, subscribe for more contents, and share this with a fellow coder who needs it. Till then, bye bye and happy coding.